All right, so we have here an equation. How do we know? Equal sign. We want to know like what kind of line this is going to make. So the first thing before anything is that we need to recognize that this is a parabola, and the reason why we know that is because there is an x squared present. Okay? More advanced is like if it was x squared and y squared, that'd be a different thing. That'd be a circle, but that's not something we need to do. So we've got the x squared, so we know, yes, this is a parabola, okay? Then the next thing we can say is, well, what do I know about it? Because it's positive, I know that it is facing up. So because it's positive, and what I mean by that is the value or the coefficient in front of the x, which is at the moment invisible, the number 1 or positive 1, tells me that the parabola is facing up. So if I write if a is greater than 0, then I have a parabola that goes like that. Okay, and a being the coefficient of the x squared, or the number that's in front of that. Okay, that's what I know. I also know that this means that it is the y-intercept. Okay, I know that that is the y-intercept, the 16. Okay, I also know that the axis of symmetry I'll just write that, is calculated by this formula here. The number in front of the x squared and the number in front of the x. So when we substitute, so we know that a is, so I'll just write them over here. A is 1 and b is 10. When we substitute, we always want to substitute with brackets so that things like minus signs and whether or not you're multiplying or dividing or plussing will hopefully be less confusing. So I'm going to replace the a with a 1, and you see there where the a was, I've got my brackets, and then the thing that people get wrong with this is that in the formula there's a negative, and then they don't transfer it in their solution. So I know that b is 10, and I've got here in brackets 10, so I've got minus 10 divided by 2, that is equal to minus 5. Okay? This here is the line of symmetry, which can be expressed as x is equal to minus 5. That is a line that goes up and down at where x is minus 5. So because I know that the middle of the parabola is minus 5, and I wanted to know, well, what's the coordinate of that position? What is the coordinate on the parabola for where it is in the middle? I can put the minus 5 back into the equation to find out what the y position is for the middle of the parabola. So if I went, okay, if I substituted that and I said, when x equals minus 5, then you can replace again with the brackets where the x is, and then the thing that I'm now running out of space for, and then the plus the 16. Minus 5 squared. What does that mean, yo? Minus 5 times minus 5. Not times 2, times itself. So minus 5 times minus 5 is 25. 10 times minus 5 is minus 50. And then I'm adding a 16. So that equals 9, minus 9. Alrighty, okay. And if this adding and subtracting negative numbers is a problem for you, you should always use a number line, okay? So the last thing we want to do, the most difficult part of this process, is determining the X intercepts, okay? This is the thing that we've been working on, okay? X intercept, or plural s. So how do we do that? Well, what we want to do is to find the factor pairs for C. All right, for C, which is the number here in the equation. So we always start with 1. 1 times 16 is 16. 2 times 8 is 16. 3 does not divide into 16. How do I know? Times tables. Or if you want to check if a number is divisible by 3, if you add the digits in the number, so for 16 that's 1 and 6, if you add them together, which makes 7, if that number is divisible by 3, then it is a factor. If it isn't, like 7 isn't, then it doesn't work. So 3 is not 1. 4 times 4 makes 16. And because in my second column of factors, I've repeated myself, I know that there are no more factors. I now need to figure out when I add them together, which one equals 10. So that would be this pair here, 2 and 8. So I put it into this equation, okay, and make it equal 0. And then I remember that the only way my answer can be 0 is if one or both of these things in the brackets is equal to 0. So to write the answer, for the first brackets, this x must be minus 2. Because when I have minus 2 plus 2, that equals 0. And then in the second brackets, I could put, that's negative 8 there. Okay? So these two are the x-intercepts for our parabola, minus 2 and minus 8. So when I draw this, if you just draw a upward facing parabola before you draw the axis lines, you can draw, so if I know that, what do I know? If I look at these two, I know that the up and down, the y-axis of the parabola, because the parabola is going through minus 2 and minus 8, that tells me that the parabola, the y-axis is roughly here. Okay? And then, so I've got my, wait, did I do that right on the line like the crazy person? I did. Okay. I meant to do it, make it wider, yo. No, you know what? I'm just gonna draw this first because that's just easier to do. Oh, okay. So here's my minus 2, here's my minus 8, here's my 16, and then my parabola goes through the middle where it is minus 5, and then it goes like this. And as you can see, that's why drawing these are hard, because you're gonna miss the places that you've marked. And this position here, the very middle of the parabola, is minus 5, minus 9.
Can you move it up a bit?
Oh, I can. Hello. All right, so that's everything. That's the parabola. That's all the details that I can give the parabola so that it has all the information. Does this thing need to scale? No, that's not important. What's important is that the way that you've drawn it and the information you've connected to the parabola is correct. Yeah. So as you can see, there's multiple components. We've got the y-intercept, the x-intercepts, the axis of symmetry, this position here, the very bottom or the very top of a parabola is called the vertex, or that position there on the parabola. Those are the bits. Any questions? Huh? Yes.
Can you upload this to YouTube over the weekend?
Yes.